Hi dear students, welcome to my channel. This video is useful for 8th standard onwards. Okay, keep watch forward, you will understand very clearly. Okay Dhruva, now what you do, slowly push the bottommost one. You observe it, when he is pushing the bottommost, the topmost also moving forward. That is because of the static friction. Now in this video, we are going to solve the problem based on this. We will write the free body diagram for this and free body diagram for this. Okay? Watch forward, you will understand very clearly. This is class number 58. We'll solve one problem. A force F applied on mass M1 as shown in the figure below. Coefficient of kinetic friction between M1 and ground is mu1 and coefficient of static friction between M1 and M2 is mu2. Both masses M1 and M2 together moving along the direction of force F with an acceleration A. Find the direction and magnitude of force of static friction between M1 and M2. This problem we will solve now. See here, this is M1, M2. Between M1 and the ground, there is a friction. The coefficient of kinetic friction is given. And between M1 and M2, coefficient of static friction is given. For each mass, first we will draw the free body diagram. Okay. For M1, you see here. On M1, right side one force F is applied. Okay. Then what should happen? This M1 should move along this direction. But who are preventing to move this M1? They are frictional forces. On M1, ground exerts a force left side. That is Fk, force of kinetic friction. Because this M1 is moving, no kinetic friction come into the picture. Another, on M1, one force of static friction exerts left side. That is M2 exerting force of static friction on M1 left side. That is Fs. Okay. So force F applied and frictional forces Fk and Fs. So the net force is along the right side because this M1 is moving right side with the acceleration A. Okay. We know the Newton's second law, net force on an object is equal to mass into acceleration. Net force is right side force minus left side. That is capital F minus Fs plus Fk equal to M1 into A. This is simple equation, F minus Fs minus Fk equal to M1A. This is equation 1. Okay. But actually, this full information is not required to solve this problem. But what is happening here, I want you should understand. Okay. Now I will come to the actual answer for this question. What only exactly required? For M2 you see, on M2, the free body diagram will write. So this M1 you are applying force F along this direction, no? Only M1 should move. Why M2 is moving? Because M2 is in contact with M1. So there is some frictional force between M2 and M1. So this M1 try to drag this M2 along its direction. That is nothing but Fs, force of static friction. So the force of static friction on M2 due to M1 is Fs along the right side. So M2 also moves with same acceleration A along this direction. M1, M2 both are moving along this direction with acceleration A. Simple Newton's second law, F net equal to Ma, that is F net is right side direction Fs, force of static friction equal to M2 into A. So Fs is equal to M2 into A. This is the answer. This is enough. Okay. So the magnitude, the direction of Fs on M2 is towards the right side and direction of Fs on M1 is towards the left side. Carefully understand. The direction of Fs on M2. M2 is right side. On M1 it is left side. M2 opposing M1 along this direction. This M1 supporting M2 to move along this direction. So this force of static friction playing dual roles. One is to take the M2 along its direction, another is to stop the M1. You're understanding? No? Carefully you have to think and solve. Okay, I hope you understood. See here, this is problem number 2. From the previous problem, M1 is 20 kg, M2 is 10 kg, mu1 equal to 0.1, mu2 equal to 0.2, and force F is 80 Newton. Find the acceleration of M1 and M2. Take G equal to 10 meter per second square. In the previous problem you understand, no? Here we are giving some values for M1 and M2 and mu1 and mu2. Same as it is in the previous problem. M1 is here, M2 is here. M1 is already you know. So one force 80 Newton applied on M1 mass along this direction. First we will draw the free body diagram for M1. On M1 downward forces, its own weight M1 G plus due to M2 also M2 G downward, no? So net force on M1 downward is M1 plus M2 into G. But it is not moving down because upward one normal force is existing on M1 due to ground, that is N1. Okay, so downward is M1 plus M2 into G, upward is N1. Right side one force 80 Newton applied, this is given. Left side the coefficient of kinetic friction already given, no? So this mass M1 and M2 moving right side, no? Because of motion of M1 and M2, there is force of kinetic friction on M1 left side along this direction, that is Fk, force of kinetic friction. And M2 also, it will try to hold the M1 because M1 want to move along this direction because of force applied 80 Newton, no? So this M2 try to stop M1. So M2 exerting one static frictional force on M1 along this direction, that is left side. So that is Fs, force of static friction. So left side forces are Fk plus Fs and right side is 80 Newton. But this mass M1 is moving right side. This is not at rest. Okay, M1 is moving right side with some acceleration that we are going to calculate. Okay, now first equations we will write. Upward force is equal to downward force. N1 equal to M1 plus M2 into G equal to 300 Newtons. Fk, force of kinetic friction, equal to mu1 N1 equal to 0.1 into N1 is 300 equal to 30 Newton, that is equation 1. Fs, force of static friction on M2 due to M1, that is simply M2 into A. A is acceleration of M1 and M2 together, M1 and M2 together moving, with some acceleration. So Fs is equal to M2 into A, that is M2 is 10, no? So 10A. So how we are getting this? On M2, this is free body diagram. Right side, the force acting on M2 due to M1, that is force of static friction. Because of force of static friction only, this M2 is moving right side with acceleration A. That is why Fs is equal to M2A, that is 10A. You are following, no? So F net, that is 80 Newton minus Fk plus Fs equal to M1A, that is equation 2. Okay, because right side force minus left side force is equal to mass into acceleration, that is equation 2. This 80 Newton minus Fk is calculated, no? That is 30 Newton minus Fs is that already we have written, no? Fs is equal to M1 into A, that is Fs is equal to M2 into A, that is 10 into A. So 80 minus 30 minus 10A equal to M1 into A. So that is M1 is 20 into A. So you can simplify it. You will get like this. 30 into A equal to 50. A equal to 50 by 30, that is 5 by 3 meter per second square. So acceleration A equal to 1.67 meter per second square. You got it? No, these are the tools to solve the problem. Once you get full confident, no, you can solve this problem fraction of minute. Okay? Please like this video, share this video, and subscribe my channel and tap the bell icon to get the notification for further uploads of my videos.